Good morning everyone. Today we are going to see about rebound hardness test. In this presentation, we are going to cover about what is hardness, followed by what is the principle behind it and what are the types, and we are going to see about some hardness testings like Euclid hardness test, Poldy hardness test, and we are going to learn what is show scleroscope and how it is used to determine the hardness, and we are going to learn about rebound angle hardness testing method, and at last we are going to see about the summary. So first of all, what is hardness? Hardness is nothing but the resistance of a material to deform. That means I am going to apply a large amount of force on a specimen. So at some point of the force, the material is going to deform. By using some mathematical calculations, we are going to give a number which is called as hardness number. So as I mentioned before, based on the loading, that means the force, the specimen is going to deform. So based on the source of loading, we are dividing the hardness into two types. One is static, another one is dynamic. So as I mentioned before, the principle is going to be the material is going to subjected to some type of indentation or impact or rebound, or it going to be an energy absorption. So generally, from understanding, we can mention that if the material is going to less deformation or the energy absorption is less, so the material is harder material. And if the material is subjected to more deformation and more energy absorbed, then the material is characterized as softer materials. So as next we are going to see about what are the types of hardness testings. So there are generally two types, which is dynamic hardness test and this dynamic elastic hardness test. We are going to see this in elaborately in the next slides. So we will see about only the three branches of the hardness testings. One is under dynamic hardness test, we are going to see about fall hardness test, and next is impact hardness test, and below dynamic elastic test we are going to see about show scleroscope type of methods, and another one is rebound angle methods. So the next is dynamic hardness test. So the main definition is it measures the hardness under impact loading instead of a static load. Here static is nothing but not gentle static, which is rest. It denotes constant load. We are not going to apply a constant load. Instead, we are going to apply an impact loading. Impact loading is nothing but a sudden loading on a specimen. So what is the principle of dynamic hardness test? Again, the same procedure is followed. A specimen is placed and the sudden load is applied such that it will go, we will measure how much it rebounded height or rebounded angle or indentation, size of indentation or energy loss. The first one is Euclid hardness test. So in this we are going to have a 3 millimeter carbide ball, and we are going to have an impact on a body impact through this carbide ball. The specimen is kept below, and we are going to apply the force using the springs, and we are going to measure how much impact and it has velocity it has rebounded through electronically. So there is a machine called Euclid machines. We can measure easily by noting the value, and it can be hardness can be calculated from velocity ratio by V2 by V1, the velocity by which without the specimen and actually by the with specimen. So the main unit is Lieb hardness, which is termed as HL in short form. So what are the advantages of this hardness test is it is very small that it is easily portable and it is fast testing. It requires less time and it is very suitable for large components. We can easily test for bigger specimen. Not only for smaller specimen, we can easily calculate the hardness for bigger specimens also. The next one is Poldy hardness test. And in this we are going to compare a specimen indentation to know the hardness. So what is the working? The steel ball is kept below the specimen as well as the hammer. In this hammer we are going to release such that it will go down and two indentation is produced on the steel ball, especially on this as well as on this, and the diameter of two indentation is measured. So the hardness is mainly obtained this Brinell hardness number. The most and important topic is Shore scleroscope. So it is a type of dynamic elastic hardness test and we are going to principle is drop hammer method. I will explain it later. I will explain it. First of all, we will have some construction part. In this shear scleroscope, we are going to have a dial such that we can measure the height of the barrel. Here barrel is nothing but the height. In this we are going to here we are going to have a ball such that it will go downwards, and we have a height adjustment knob such that we can determine the highness. If I want a more height, we can increase the height of the scleroscope. If I want less height, and I am going to reduce the scleroscope height. For that we are using this part. Anvil is nothing but the specimen we are going to place, that part is known as anvil, and we have a control knob such that we can able to tight the specimens, and we are going to place a workpiece on the anvil, and we can easily see there is a tip of the hammer so that it will have an impact. So that is the glass tube, which is the barrel, consists of 25 centimeter, and the hammer, here we can place there will be a hammer tip which is 2.5 grams, and it will the indenter is nothing but the device that is used to measure creates the indentation is called indenter. Here that is diamond point indenters, and we are going to measure how much the height it will be rebounded after giving an impact to the specimen. So the unit is shore hardness. We are going to measure the shore hardness. So the next is working is, as I said before, hammer is released from a fixed height. The fixed height is adjusted through this height adjusting knob, and then it will strike the specimen and it will be rebounded. The rebounded height is measured. So I am going to place a thing such that it will be go down and it will strike the specimen here, and it will be rebounded back, and it will be measured in the height dial. So what we observe is it will be highly rebounded. So if it is coming back like this and it will be rebounded to a greater height, then it will be a hard specimen. If I am going to rebound it like this and the rebounded height is less, then it will be like a softer specimen. This is the main thing that is behind the shore scleroscope, through which we can determine the hardness. So there are two types of a scleroscope. One is model C and another one is model D. So model C is actually made for engineering materials. It consists of a diamond tipped, and it is mainly used for steel and medium hardness materials. And we have a standard shore's hardness scale, and it will be like a precise. It will not be precise compared to model D. In model T scleroscope, we are designed for harder materials, and it will have a heavier hammer compared to C, because in model C we are using only for steel and medium, whereas it is used for harder materials, so it have a heavier hammers. So it will be used for very hard steels and alloy materials. It is more accurate, and it will be not accurate compared to C. C is less accurate, whereas D is more accurate. The final part is rebound angle method. So here the specimen is placed vertically, and we are going to have a pulley, and we are going to, the steel ball is hung using a thread, and we are going to release this steel ball or any type of indentar such that it will go like a parabolic path, hit the specimen, and it will be rebounded back. The amount of initial angle and the amount of rebounded angle is measured, and such that we will determine the hardness of the material. The main principle is hardness determined from angle. Angle is main important, and as I said before, working pendulum, we are going to release the pendulum, and we are going to strike it, and it will be come back. Rebounded angle is nothing but alpha naught. So the main concept is, if the rebounded angle is very high, consider this as a rebounded angle. If it is very high, it will be like a harder material. Suppose if the rebounded angle like this very short, then it will be like a softer material. So what is the advantages and disadvantages of dynamic hardness testing? It will be like a portable equipment. It will be quick testing. It will not take more than 5 minutes to take this test, and we can easily do it for heavy components, and it will get minimum damage. It is not completely destructive, but it will be having like small amount of damage only, and it will be like a less precise compared to static hardness test, which is the main disadvantages in the dynamic hardness test. And we are going to have some conditions to apply these type of test, and it is not applicable to brittle materials, only it will applies to ductile materials. So we have reached the last part, which is the summarized part. As already, this evaluates the materials under impact loading, and it will measure the rebounded height, angle, indentation or energy loss. Some of the common method is fall using source scleroscope, rebounded angle, Lieb hardness test, Poldy hardness test, etc. So these methods are very fast, and we can use for very larger components, but it is very less precise compared to the static hardness test. So the reference book I have used is Mechanical Metallurgy by George E. Dieter, and then thank you.